Hi there, everybody. This video is about congruent triangles. Now, first of all, what in the world does it mean for triangles to be congruent? Um, triangles that are congruent have all the corresponding parts are the same. So these two sides are equal in length, these two sides are equal in length, these two sides are equal in length. But not just the sides, the angles as well. These two angles are the same, these two angles are the same, these two angles are the same. They have three pairs of corresponding sides that are the same. They have three pairs of corresponding angles that are the same. That's what congruent triangles are. They're exactly the same size and same shape. Same size, same shape. Where similar triangles, we've talked about similar triangles in the past, similar triangles are only the same shape, right? You enlarge a square, it's still a square, but it's a different size. Okay? Similar triangles are just the same shape, not necessarily the same size. Congruent triangles, same size and same shape. So how do we know when triangles are congruent? Do we have to show that all 6 of these pairs of things are the same? Or is there a shortcut? Thankfully, the answer is there are shortcuts. There are actually several shortcuts that we'll see in a second. Before I get to that, I want to write a statement here that says that these triangles are congruent. Let's call this triangle WHS. The symbol for congruent is an equal sign with a squiggle above it. Okay. The squiggle by itself just means similar, okay, but the equals with a squiggle means congruent. And just like with our similarity statements, our congruent statements, the points, they have to go in the same order. We started with W, that means we got to start with P over here. Next came H, means we got to go to A next because H and A are the same. S is what we ended with. That one's equal to N, so we got to end with N here, and that's called a similarity statement. Okay, so now let's talk about some shortcuts. How do we know when triangles are congruent? So let's say that we have 2 triangles, and all we know are that the 3 pairs of sides are the same. That's all we know. We don't know anything about the angles. The question is that enough for us to say that the triangles are congruent? Well, let's look at this a little more deeply. Let's back up a step and say, are these similar? Just for the heck of it, let me put some side lengths here. Are these triangles similar? Well, 4 and 4, if we were going to show that they were similar, we would use side, side, side similarity because we have all 3 sides for each one. And we go 4 over 4, that equals 1. 5 over 5 equals 1. 6 over 6 equals 1. All the side ratios are the same. That means these triangles are similar. Now, since the triangles are similar, we also know that that means that the corresponding angles have to be the same. So if the corresponding sides are all the same, then these corresponding angles have to be the same too. So we've got, if the 3 sides of this are the 3 pairs of sides are the same, then the 3 angles are the same too, and we've got this situation here. So this is enough information for us to say that yes, the triangles are similar without knowing anything about the angles. And so let's see. We'll say if 3 pairs of corresponding sides are equal, then the triangles are congruent. Holy cow, that is a mouthful. It would be nice if we had a shorthand for that. And there is, just like with the side, side, side similarity, angle, angle similarity, side, angle, side similarity that we used for showing triangles were similar. There is a shorthand for this as well, and it's simply side, side, side. When we were talking about similarity, there was a little similarity symbol after it, a little squiggle. When you leave it off, we use that for meaning that triangles are congruent. So that just means, this SSS just means that we have 3 pairs of sides three pairs of sides that are the same. Therefore, the triangles are congruent. So that is one shortcut. It's called side, side, side. Let's look at another one. What if we have two pairs of sides with the angle in between them the same? Is that enough for us to say that the triangles are congruent? Well, again, let's look at similarity. If we take this side and divide it by this side, we get 1 because they're the same. This side divided by this side, they're 1, they're the same. The angles in between them are the same. These triangles are similar by side angle side similarity. And since they are, these two sides have to give us the same ratio as these two, which was 1. So these two sides are the same. Now we've got this situation, right? We would know that these two sides had to give the same ratio as these other two because they were similar. The triangles are similar. That means we've got this. So these triangles are congruent. And the reason is side, angle, side. We've got an angle between two sides that are the same in the two triangles. And I could write this if-then statement showing this. If two pairs of sides are the same and the angle between the two sides are the same, then the triangles are congruent. And that's side, angle, side. And it does work for showing triangles are congruent. So we got side, side, side. We got side, angle, side. What else do we have? Here we've got two pairs of angles that are the same and a side in between them. Is that enough? Well, again, let's go back to similarity. Are these triangles similar? The answer is yes by angle, angle. Since they're similar, that means these pairs of angles are the same. Now, it also means that all the side ratios are the same. The side ratio of these two is 1 because these are the same. This divided by this would be 1. That means these two would be the same. This side ratios would be 1. And these side ratios would be 1. They'd be the same too. So these triangles are congruent. And the reason is angle, side, angle. We've got two pairs of angles the same, right? And a side in between the angles that are the same too. So if we have two pairs of angles that are the same and a side in between them that are also the same, then the triangles are congruent. And that's called angle, side, angle. Here's another one. Does this work? Yes, it does. And this is called angle, angle, side. Now, these are a little different here. Here, the side is not between the two angles. Okay? The side that we know is the sides that we know are the same are not between the two angles. So this is different. Angle, side, angle, and angle, angle, side are different. And they both work for showing triangles are congruent. These triangles do have to be congruent for the same reason we've been using. They're similar, and so on. Now there's one more, and this one only involves right triangles. We've got hypotenuses that are the same, right? The sides that are across from the 90-degree angle are the same. And we've got one pair of legs that are the same also. These triangles are congruent. And the reason that we give is we use a shorthand hypotenuse leg, because the hypotenuses are the same and one pair of legs are the same. And I mean, we could do the same thing again. Let's say these are 3 and 5. We could use Pythagorean theorem to find the third side in each triangle. We would see that they're the same. Now we've got side, side, side. So you don't have to do that extra work. If you know the hypotenuses are the same, you know one pair of legs are the same in a right triangle, you automatically know the triangles are congruent. So hypotenuse leg works too. 5 ways. Hypotenuse leg for showing triangles are congruent. Hypotenuse leg, angle, angle, side, angle, side, angle, side, 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 and side, angle, side. Okay. Hope that makes sense. See you later. Bye.